Grassfire algorithm. This project, this Python program is designed to simulate a grid-based pathfinding scenario where obstacles are placed and a path is calculated from a starting cell to a destination cell. But in Grassfire algorithm, we usually start calculating from destination cell to the starting cell using a simplified version of Grassfire algorithm. Once the path is being calculated, it uses the matplotlib library to visualize the grid, the obstacle, the starting and the ending points, and the path it takes. So here on my program, as you can see, I started by importing importing matplotlib patches and pilot and numpy. Then I just declared my constant variables, and then I have a function called prompt grid size. This function asks the user to input the number of rows and columns for the grid, ensuring they meet the minimum size requirement. And also, I have another function here called create obstacle set. This function generates a set of unique obstacle position based on the grid size and the percentage of the grid that should be obstacle. And then I have another function that is called select starting position. This function randomly selects the starting cell's column index on the first row of the grid. And then I have another function called select destination position. This function randomly selects the destination cell's position based on the criteria that it should be in the lower half of the grid and to the right side in terms of the column. And my last function, this function implements the pathfinding algorithm that marks the distance from the destination cell to all other cells. And then it backtracks to find the shortest path from the start cell to the destination cell. And then I have another function called visualize grid. So this function uses a matplotlib to draw the grid, the obstacles, the starting and the ending cells, and the path if one was found. The starting cell is labeled start, and the ending cell, destination cell, is labeled as end. And then I have the main function here that just execute the main or the function that I've been declared on my program. And also I have the if name is equals to main. The if name is equals to main part ensures that the main function is called only when the script is executed as the main program, not when it's being imported as a module in another script. So in the prompt grid size function, you can see I just declared that rows and columns are equal to 0. But in the beginning, as you can remember, I already put like my min rows and my max rows equals to 8 as the required as a constant variable. And then I'm using a while loop so that I can check if the condition is true. So I'm checking while rows are less than min rows or columns are less than the mean columns, then I'm trying to use a catch, uh, try and except so that I can catch the error. So I'll just prompt the user to input the number of rows and columns, and then if there is an error, I'll just tell them to please enter integer values only. And then I'm also checking to validate if the condition is true. If rows less than the mean rows or columns, then I'm just gonna the grid must have the minimum rows and the minimum columns of 8 by 8. And then I'm gonna return rows and columns. And then for creating obstacle, here I'm just gonna generate a set of unique obstacle position based on the grid size and the percentage of the grid that should be obstacle. So I'm just declaring number of cells, number of obstacles by rounding it with the percentage, timesing by 100, and then timesing the number of cells. And the number of cells, remember, I got them by multiplying number of rows and number of columns. And then I'm trying to put the while loop so that I can be able to check for the condition. And then also for the select starting position, this is just very straightforward. I'm just using random numbers so that you can just randomly select the starting cells column index and on the first row of the grid. And then I have select destination position. So this function randomly selects the destination cells position based on the criteria that it should be in the lower half of the grid to the right side in terms of the columns. So I'm just saying like row threshold is equal to number of rows, and then I'm trying to find the remainder by dividing it by 2. And also I'm looking for the column threshold by rounding it off by 2 divided by 3, just making sure it's on the lower half on the right side of it. Then for the Grassfire algorithm here, I'm passing parameters, obstacle, starting point, destination point, number of rows, and number of columns. And then I'm using NumPy just to make sure keep all the arrays and the numbers. And it goes in case of the time. So I'm just gonna demo it so that you can be able to see. So gonna run my program here. And then it's gonna ask me for the number of rows. I'm gonna put 8. Number of columns, I'm gonna put 8. Should be able to see. Okay, didn't work. Let me try again. I clear my run the program again. 8, 8. And then here it shows the start and the end of the column. And then it's just gonna show the path that it took us, the shortest path to get here. I'm gonna try it again to see if it's more accurate. Clear this. Okay. I'm gonna run my program. Put 8. Put 8. I don't know why it's not working. I'll run it again. 8. 8. It was working. Yeah, so now it's more accurate. So it shows that it took the shortest path to get here. Yeah, so that's it about my project. Thank you so much.